In this topic, we will learn about the Internet of Things, IoT, connecting the physical and digital worlds. The Internet of Things, IoT, is transforming industries by connecting the physical and digital worlds through intelligent connectivity and real-time data exchange. IoT allows us to collect and analyze vast amounts of data from connected devices, sensors, and systems, providing valuable insights that can drive innovation and optimization across various sectors. This slide introduces the key concept of IoT and highlights how it is enabling the convergence of the physical and digital realms, leading to new opportunities for businesses and industries. The image on the right depicts a modern smart city with a network of connected devices, illustrating the interconnected nature of IoT and its potential to create more efficient and responsive urban environments. The core of any IoT system is a multi-layered architecture that brings together hardware, connectivity, data processing, and security. At the foundation are the physical devices, the sensors, actuators, and embedded systems that collect raw data from the real world. This data flows up through connectivity layers, using protocols like Wi-Fi, Bluetooth, or cellular to connect the devices to the broader network. The data is then processed and analyzed. Often in the cloud using powerful computing resources and advanced analytics, security is woven throughout the entire architecture to protect the data, devices, and systems from threats. This layered approach allows IoT systems to transform raw sensor data into valuable business insights and intelligence. Understanding this core architecture is key to designing, deploying, and maintaining effective IoT solutions. IoT, or the Internet of Things, refers to a network of interconnected devices that can collect, exchange, and act on data without human intervention. These connected devices form an ecosystem that enables intelligent automation and data-driven insights across various industries. The key aspects of IoT are: connected ecosystem. Devices are networked together to share information and coordinate actions. Intelligent automation. IoT allows for real-time monitoring and smarter decision-making to automate processes. Data-driven insights. IoT transforms physical environments into intelligent systems that continuously learn and optimize based on the data they collect. The six-layer IoT architecture provides a comprehensive framework for building connected systems. At the bottom is the perceptual layer, where smart sensors and actuators gather data from the physical world. The network layer handles secure and efficient data transmission between devices using technologies like Wi-Fi, 5G, MQTT, and CoAP. The edge computing layer processes data locally to reduce latency and bandwidth usage, enabling faster response times. The data processing layer uses cloud platforms like Azure IoT Hub and AWS IoT Core to analyze and store data at scale. The application layer delivers IoT services tailored to specific industries and use cases. Finally, the security layer protects the entire IoT ecosystem from cyber threats. Sensors are the input devices that gather data from the physical world for IoT systems. They measure a wide range of environmental parameters like temperature, vibration, motion, moisture, pressure, and more. Sensors serve as the eyes and ears of IoT, continuously collecting data. Examples of common sensors include temperature, humidity, motion detectors, vibration monitors, and environmental quality sensors. Actuators are the output devices that allow IoT systems to influence their environment. They convert digital commands into physical actions, bridging the gap between digital intelligence and the physical world. Examples include smart thermostats, automated valves, robotic arms, and lighting systems. The combination of sensors and actuators is what gives IoT systems the ability to sense, analyze, and respond to their surroundings. As an example, vibration sensors with edge computing can detect machine anomalies in real time, triggering alerts and preventive actions before failure occurs. The fourth industrial revolution, or Industry 4.0, is being driven by the rise of IoT, Internet of Things connectivity. This is transforming traditional manufacturing facilities into smart, adaptive ecosystems that can optimize themselves in real time. The key enabler is the interconnectivity of devices, systems, and data across the factory floor. This allows for real-time monitoring, analysis, and autonomous adjustment to improve efficiency, productivity, and quality. The image shows a modern smart factory with robotic automation and a digital network. This represents the vision of Industry 4.0 highlight how IoT is the foundation that enables this transformation from traditional to smart manufacturing. The factory floor is being transformed into an intelligent ecosystem through the power of IoT and digital connectivity. Real-time data from machines, sensors, and control systems provides continuous visibility across all operations. Predictive maintenance powered by AI can reduce downtime by 22% through early failure detection and proactive maintenance scheduling. Improved product quality and resource efficiency. With gains of 15% or more reported across manufacturing sectors, cloud-based IoT platforms enable global operations management, scaling securely to millions of connected devices. The Middle East and Gulf region is experiencing rapid growth in industrial IoT, IIoT adoption. This slide highlights some of the real-world impacts that GCC manufacturers are seeing from IIoT: 22% reduction in downtime through predictive maintenance capabilities, 18% energy savings from IoT-driven optimization of energy consumption, 26.1 billion projected market growth for IIoT in the Middle East and Africa by 2029. IoT is enabling dramatic improvements in operational efficiency and sustainability for manufacturers in the region. These technologies are transforming production cycles and reducing waste. The slide introduces the topic of IoT data collection and real-time analytics in AR/VR systems. It highlights how the convergence of IoT and AR/VR technologies creates immersive environments where operators can interact with real-time data in new ways. This convergence is revolutionizing training, maintenance, and operational oversight in various industries. The image on the right depicts an augmented reality factory worker interacting with digital overlay data visualizations, illustrating the concept. Key points to emphasize are the transformative potential of combining IoT and AR/VR, and the new ways operators can engage with real-time data in IoT sensors are feeding real-time, continuous data into these AR/VR environments. This allows for much more immersive monitoring and interaction with the data, and virtual models. Digital twin technology is mirroring physical assets with high precision in these virtual worlds. This enables predictive insights about the physical systems and even remote control capabilities. Powerful AI-powered analytics are extracting valuable intelligence from all the streaming sensor data. This intelligence can inform smarter training, maintenance, and operational decisions in manufacturing and other industries. The combination of IoT, AR/VR, digital twins, and AI is unlocking new frontiers for industrial applications. The rise of IoT ecosystems has brought significant security and interoperability challenges that must be addressed. IoT systems are highly interconnected, which introduces complex vulnerabilities that can impact the safety and reliability of operations. We need to find ways to ensure secure, reliable connections between these diverse, complex systems. Securing IoT ecosystems and enabling seamless interoperability is crucial as these technologies become more widespread. The IoT ecosystem has an expanded attack surface due to the vast connectivity of IoT devices, making them vulnerable to DDoS attacks, device hijacking, ransomware, and data breaches. Legacy industrial protocols like Modbus lack encryption, exposing industrial networks to interception and manipulation by malicious actors. Cyber attacks on IoT systems can have critical impacts, disrupting production lines, causing intellectual property theft, and even risking human safety in industrial environments. Securing the IoT ecosystem requires a modern security framework, including network segmentation, encrypted protocols, zero-trust architecture, and AI-driven threat detection systems. Diverse IoT devices and protocols require standardization for seamless communication across manufacturers, platforms, and systems. Lightweight, efficient messaging protocols like MQTT and CoAP enable smooth data exchange between heterogeneous devices. Cloud platforms provide a unified way to manage and integrate diverse IoT devices and ecosystems. Open standards are crucial to facilitate interoperability and prevent vendor lock-in. API-driven integration enables effortless data exchange between different systems and components. This case study explores how leading manufacturers are using IoT-enabled digital twins to connect the physical and virtual worlds. Digital twins allow for unprecedented visibility and control over complex industrial operations. The slide shows an image of a virtual reality simulation of an industrial plant, highlighting the integration of digital twins with VR technology. Key benefits of this approach include real-time monitoring, predictive maintenance, and optimized decision-making across the entire manufacturing process. I'll dive deeper into specific use cases and the technology behind these IoT-powered digital twins in the next few slides. IoT sensors continuously feed real-time data on machine performance, temperature, vibration, and other operational parameters into the VR digital twin. This allows operators to visualize the current status of equipment and predict potential failures before they happen. Using VR headsets, operators can explore the digital twin in an immersive 3D environment to troubleshoot issues and simulate repair procedures. The VR digital twin is linked to the actual industrial plant, enabling 24/7 remote monitoring from anywhere in the world. This results in reduced downtime, faster troubleshooting, enhanced worker safety, and significant cost savings across the plant's operations. The key message of this slide is the powerful synergy between the physical and digital worlds, enabling real-time insights that drive real-world impact. The split-screen visual effectively contrasts the physical factory floor with the virtual digital twin interface, illustrating how the two are converging. Highlight how insights gained in the virtual environment can be immediately applied to optimize physical processes, creating a continuous feedback loop for improvement. Emphasize how this convergence unlocks unprecedented visibility and the ability to make rapid, data-driven decisions that enhance operational efficiency and performance. Tie this back to the overall theme of the presentation, how this technology is transforming the way organizations operate and compete. The Internet of Things is revolutionizing industries by merging physical assets with digital intelligence, creating adaptive ecosystems that continuously learn and adapt. Success in IoT depends on having a robust architecture, real-time analytics capabilities, and strong cybersecurity measures in place. The convergence of IoT with emerging technologies like AR, VR, and AI unlocks unprecedented operational insights and competitive advantages for organizations. Embracing IoT is critical for driving innovation, efficiency, and resilience in the digital age. I encourage you all to explore how IoT can transform your business,